Okay. Hey everyone, so my name is Nikita Chandra from Industrial Engineering Department, BINUS Graduate Program. And today I will present our study on developing decision-making model to enhance import procurement efficiency using a hybrid Lean Six Sigma and machine learning approach. Okay, so the import procurement in manufacturing faces several critical challenges, including the freight and exchange rate fluctuation, uncertain Incoterm selection, and frequent changes in government regulation. This condition lead to high variability in total landed costs, which directly impact cost control and weakens the managerial decision-making. In practice, many companies still rely on historical average to estimate landed costs. However, this approach is unable to capture the nonlinear relationship among procurement and logistic factors, especially in a volatile global environment. The research gap of this study is Lean Six Sigma provides a strong and structured improvement framework through the MAKE, but it has limited capability in handling nonlinear relationships and external uncertainty. On the other hand, machine learning offers a strong predictive performance, yet it's often applied as a standalone tool and not embed within continuous improvement frameworks. Therefore, the key research gap lies in the lack of studies that integrate machine learning as a decision support engine within the MAKE framework, particularly for import procurement and landed cost control. And this study aims to fill that gap by developing a data-driven decision-making model that combines Lean Six Sigma and machine learning. This study uses procurement records from an Indonesian packaging manufacturer engaged in global sourcing. The dataset consists of 242 import procurement transactions recorded between 2023 to 2025. The target variable is a total landed cost expressed as a percentage of purchase order value, which must not exceeding the company's managerial threshold of 30%. To model landed cost behavior, we compared three ensemble machine learning models such as a random forest, an XGBoost, and a gradient boosting. Among these three models, the gradient boosting achieved the best predictive performance and was selected as the analytical engine. The root cause analysis shows that high landed cost variability is primarily driven by procurement configuration decisions rather than the price alone. The most influential factors are Incoterm selection, transportation mode, shipment size, and consolidation strategy. These factors interact in a nonlinear manner, which explains why conventional statistical approaches struggle to support effective decision-making in import procurement. The key results. Under the baseline condition, 42.9% of transactions exceeding the 30% landed cost threshold, corresponding to a sigma level of approximately 1.7. Using the gradient boosting model, several procurement scenarios were evaluated, and the result is the FOB-based configuration delivers the best improvement. As a result, the defect rate decreases from 42.9% to 45.3%. Also, the DPMO is reduced for 427,000 to 413,000. The average landed cost decreases by approximately 2%, and this improvement raised the sigma level from 1.7 to 1.8. Sensitivity analysis also further shows that the gradient boosting based strategy delivers the greatest benefit under the stricter landed cost threshold, explaining why a modest sigma level increase in managerially meaningful. Conclusion and implication. In conclusion, this study demonstrates that landed cost issues in import procurement are driven mainly by decisions configuration rather than the price fluctuations alone. Integrating machine learning into the Lean Six Sigma domain framework strengthens the data-driven decision-making and supports more consistent cost control. From a managerial perspective, these findings suggest a prioritizing FOB Incoterms, matching transportation modes to shipment size, and continuously monitoring TLC or total landed cost, defect rate, and sigma level. However, this study based on historical data from a single company, which may limit the generality in the study. Also, the 30% TLC threshold is managerial defined and would benefit from broader benchmarking. External market description are also explicitly modeled. Future research might extend this work to multi-industry setting and a real-time decision support system. Okay, I think that's all from the study. Thank you for your attention. I welcome any questions or discussion.